So, let us have a quick review about mean value theorems in the area of differential calculus. Broadly, we can discuss Lagrange's mean value theorem, which states that if a function f x defined on some interval a b is continuous on closed interval a b, differentiable in open interval a b, differentiable in the sense possessing only the first derivative, there exists C belonging to the open interval a b such that f dash c is equal to f of b minus f of a by b minus a. So, this c can be more than one c, it can be at least one c, that is what the theorem prescribes. When it comes to the generalized mean value theorem, this generalized mean value theorem, which is also called the Taylor's theorem, this says if a function f of x defined over the interval a to b has got derivatives of all orders up to n, which are all continuous, then suppose you take the interval to be a comma a plus h, then the Taylor's theorem statement is f of a plus h is equal to f of a plus h f dash a plus h square by 2 factorial f double dash a and so on, plus a remainder term which is generally denoted by R n. This remainder of course can be designed differently. The more popular one is called the Lagrange's form of remainder. Anyway, what is very important about the Taylor's theorem is it leads to the Taylor series. Now, when you look at the Taylor series, f of a plus h is equal to f of a plus h f dash a plus h square by 2 factorial f double dash a and so on, where h is equal to the width of the interval. Suppose the interval is a comma b, then it is b minus a and so on and so forth. Now, you can write the Taylor series to any degree of approximation. Suppose you want to expand the Taylor series to first degree approximation, then you take only the first two terms, that means up to the first derivative. If you want a quadratic approximation of Taylor's, you go to this particular level. And then a particular case of Taylor series is what we call the Maclaurin series. Maclaurin series comes from Taylor series by putting a is equal to 0 and h is equal to x. In fact, in Taylor series we can slightly modify this. We can make h is equal to x minus a by adjusting the interval accordingly. So, therefore, we can have a plus h is equal to x. Therefore, we can write a Taylor series with the left hand side as f of x. So, when we actually come to problems, I will show you how we can use Taylor's Maclaurin series for finding out various coefficients or building a series to a certain level.